grade 10s. Today we are doing our last little bit on functions, where we're going to look at the types of questions that you're going to get in exams and tests. Now, in most exams and tests, we don't actually ask you to plot anything. We give you a plotted function or a graph, and then we ask you questions about it. Now, just to do a little bit of a recap, remember that a graph is the plotted relationship of a function. And a function is a relationship between two variables where you only get one output variable for every input variable you substitute in. Typically, your input variables are x and your output variables are y. Now, we've done 7 functions so far, so let's just look at those quickly. And we see on the next slide that we have done a straight line, that's a linear function. We've done a parabola, which is a quadratic function. We've done a hyperbola, and that's the one where x is in the denominator. And remember, when x is in the denominator, it cannot equal 0. So we have asymptotes. Okay, and it's got a very funny spelling, but there it is. And then we've done the exponential function, which also has an asymptote. And with this one, it's got a b value, and b can't be less than 0, and it can't be equal to 1. So it's either between 0 and 1, or it is more than 1. Then, of course, last week we did the sine, the cosine, and the tangent graphs, which of course are linked to the trig ratio sine, cos, and tan. Okay, now the majority of the questions that are asked in assessments focus on interpreting a graph, which includes finding the value of a point, determining the distance between points, determining the equation of a function, state the domain, the range, amplitude, or period, and find where one function, where one function is above the other. Okay, so like in a straight line and a parabola question, we would ask, where is the parabola above the straight line? And the parabola is above the straight line between this point and this point. So we would give our answer as an inequality with x in the middle. So that would be 0, and let's make that up as 0.3. Okay, so those are the different types of questions that you're going to be asked. Now, over the last 3 weeks, we have looked, or I've given you 3 different challenge questions. And those challenge questions are the basis of today's lesson. So we're going to go through each one, and hopefully you've got your answers with you so that you can check yours against mine. Now, many people look at interpreting functions, these kinds of questions, as difficult. They're really not. It's just taking what you know and applying it. And if you think about what the question is really asking, rather than getting confused about the English, it's a lot easier. So much easier. So I'm going to give you a bit of a lesson on how to get through that stress as well. Let's take a look at our first question. Now, our first question comes from the first show of this term, and it says the graphs of y is equals to x and y is equals to 8 over x are shown in the following diagram. Okay, so we can see that y equals 8 over x is a hyperbola, and a hyperbola, as we know, has 2 asymptotes. So there's the hyperbola, and then the y is equals to x is our straight line. Okay, we can also see a whole lot of other things that are indicated. We have a point C, which has a perpendicular drop down to point B. Then we have a point F, which will be that point over there, and point E, which will be this point over here. And G is obviously the perpendicular going down to F as well. Then point D lies on the x-axis and has a perpendicular line drawn up to point A. Now what do you notice about point A? If you said that's where the pink function and the purple function intersect, then you would be correct. And here's your smiling face. Look, B is also a point of intersection for all the two functions. So these are the types of things that we should start noticing. We haven't been given any questions yet. We've just been told the graphs of y is equals to x and y is equals to 8 over x are shown in the following diagram. Okay, so that means we now need to figure out what the questions are. Calculate the coordinates of A and B. Find the length CD. Calculate the length of AB. Oh, so we need to answer question A to get question C right. And then find the length of EF if G is the point -2 and 0. Okay, well, shall we begin? Now here we have the diagram repeated. And the first question was to calculate the coordinates of A and B. And we've already said that those were the points of intersection. So those are points of intersection of the graphs y is equals to x and y is equals to 8 over x. Now grade 10s, if we think about this logically, a point of intersection is where the two graphs meet each other. So that means at that very point, the x value for the one function is going to be the same value as the x value for the other function. And the y value for the one function is going to be exactly the same value as the y value for the other function. The point is exactly the same on both of them. And you'll remember from a few weeks ago when we did simultaneous equations that in order to find these, we just need to substitute the two equations into each other. Now we're lucky because already the equations are y is equals to and y is equals to. And we know that because both y's have exactly the same value, we can just make the two equations equal to each other. Okay, I'm going to show you how to write this down algebraically, but really it should be quite easy to find the answer. Let's do it. Okay, so we're going to call the first equation, equation 1, and the second equation, equation 2. And we'll substitute 1 into 2. So that means we've got x is equals to 8 over x. And that means we have x squared is equals to 8, which means that x is going to either be equal to the positive square root of 8 or x will equal the negative square root of 8, which I'm sure you know is x is equals to 2 square root 2 or x is equals to negative 2 square root 2. Now, have we found all the values we need? No, we still need to find out what our y coordinates are. And I'll show you what I mean. We have an x coordinate for A. Now, x coordinate for A is going to be 2 square root 2. And our x coordinate for B is going to be negative 2 square root 2. But in both of these cases, we don't know what y is going to be. So we need to do some substitution. And I'm going to say over here, subs x into equation 1. Why have I chosen equation 1? Because equation 1 really is the more easy one. Y is equals to x. So therefore, y will either be 2 square root 2 or y is going to be negative 2 square root 2. Let's extend the page. So therefore, our points are 2 square root 2, 2 square root 2, and negative 2 square root 2, and negative 2 square root 2. Let's go back to our graph and figure out which one is A and which one is B. Well, A is the positive one, and B is the negative one. So I'm going to write A as our positive coordinate. So A is this one, and B is that one. Okay, grade 10s. So all we had to do for that question, whenever we find a point of intersection, is to make the two equations equal to each other. Once we've done that, it's just straightforward simultaneous equations. We find the value for x, then we find the value for y, and then we figure out which coordinate has which value. And after that, we're able to use those values in other questions. Okay, you ready to do the next question? Let's move on. Now the next question has the same graph repeated so that we can use it again. And it says, find the length of CD. So let's go back and look at the coordinates of CD. C was a perpendicular dropped from B, and D was the perpendicular dropped from A. So I know that the value, the x value of D is going to be 2 square root 2, and the y value is going to be 0. And the x value over here is negative 2 square root 2. Whoops, see, I put a semicolon too close. And the x value, or the y value, is going to be 0. So in order to find the distance between those 2 points, I need to find the difference between those 2 points. So how much distance is there between these 2 points? Well, let's figure that out. 2 square root 2 minus 2 square root 2 is equals to 2 square root 2 plus 2 square root 2, which is 4 square root 2. Now I know that some of you are going to get confused with this, so I'm going to change it to an algebra problem just to help you out a little bit. Think of the square root 2 as A. Let's call it A. That means that we have 2A minus 2A, which gives us 2A plus 2A, which is equals to 4A. And look what happened over here. A. So it all works out, and everyone's a happy camper. Okay, I know I didn't answer this on the slide, but at least we can go on to the next question. The next question says, calculate the length of AB. Now this is a bit of a tricky one, because you'll remember that AB looked like something like this, and we had negative 2 square root 2, negative 2 square root 2, and it went up to 2 square root 2 and 2 square root 2. Now I'm going to use Pythagoras to calculate the distance over here. I'm drawing in a right angle triangle, and I'm saying that this distance over here is equals to 4 square root 2. And this distance over here is also equal to 4 square root 2. So if I want to find out what r is, I'm going to use Pythagoras, and go 4 square root 2 squared plus 4 square root 2 squared, which of course means that r is equals to the square root of 32 plus 32, which is the square root of 64, which is equals to 8. Okay, feel free to check me on your calculator, but I'm pretty sure I'm correct. Now, grade 10s, before we go on, it's just time to have a bit of a break. Stretch out your muscles a bit, check through your calculations, and then sit down and be ready to work. We'll see you just now. Welcome back. Are you feeling nice and relaxed? Did you stretch out those muscles? I hear that if you pull on the fingers and you wiggle them around and you shake your hands and you shake it all out, it actually gets your brain working again. So when you get stuck in an exam and you're struggling to think again, just pull your fingers a little, wriggle them. I've also heard rubbing your ears helps, and shake it all out. I promise you, you really do feel better after a good stretch and a good shake out. Okay, we still have one question left of that previous question before we move on to the second challenge question. So let's take a look at that. On screen, we have the same graph again. We have calculated, so far, we have calculated the value of point B, the value of point A. We've calculated the distance between C and D, and then we've used the distance between C and D to calculate the length of AB using Pythagoras. So we have a value of 8 for that length. The last question says, find the length of EF if G is the point -2 and 0. Okay, so let's put the value of G, first let's get rid of all of my scribbles. Let's put the value of G in here, and it was -2 and 0. And we need to find the length of EF. Now, let's think about this. If G has a value of -2 and 0, it means that F will have a value of -2 and something. And E will have a value of -2 and something. And what we really need to find out is the difference between those two values over there. So how are we going to do this? And I'm just going to answer this over here. We're going to substitute the value of -2 into both of these equations. So that means in the equation y is equals to x, it becomes y is equals to -2, giving us a value for the straight line at F is -2. Now let's do point E. Y is 8 over -2, which means y is equals to -4. Okay, now what does that tell us about the difference between these 2 points? If I want to travel from -2 to -4, how many units am I covering? If you said 2, you would be correct. Now let's see how you do that mathematically. So I am going to take the distance of -2 and I'm going to subtract -4 from it. And that gives me -2 plus 4, which gives me an answer of 2. But really, I didn't have to do that. I could have just said there are 2 units between the 2 functions, or the distance of EF is 2. Okay, grade 10s. I hope you've seen, as we've gone through this, that none of those questions were actually difficult. It was more the way the question was presented, and we have spoken about this before, how maths teachers, how we like to give you grannies in bikinis. We know everyone loves spending time with that lovable granny, the one who makes you cookies and stuff like that. But Nobody wants to be seen in public with a granny who's wearing a bikini, especially a really old granny who's wearing a bikini. And that's very much what's happening in these questions. The questions are fine, they're easy, they're things that make us feel good. But as soon as we dress them up and we put them all together in one big mixing bowl, it looks terrible. And because it looks terrible, we think we can't do it. But I know you can. It's all in your mind, and you can do this. Okay, the next question has two parabolas in it, and then it asks some questions about the two parabolas, and once again we'll be interpreting them. With this one, we're going to need to find the equations of the parabolas. So I want you to think very quickly, how did we find the equations? Do we need to use the y-intercept? Do we need to use the x-intercepts? Start pondering it, and I will change our slide, and we'll look at the equations. Two parabolas are drawn. G of x is equals to ax squared plus p, and h of x is equals to bx squared plus q. So let's do this slightly more cleverly, and I'm going to make g of x pink, and there it is. Just trace over it. So g of x is the happy one, and h of x I'm going to make purple, and it's the sad one. Now we can also see that we've been given the points of intersection, and it's 4 and 7, and -4 and 7. Now because you've had time to do these questions already, I'm not going to give you time to do them right now. We're just going to go and look at the questions immediately. So, question says find the values of a and p. Now those were in the equation of g of x. Then we needed to find the values, or we need to find the values of b and q, and those were in h of x. So h of x, and the top one was g of x. Then we need to find the values of x for which h of x is more than g of x. And we're going to go through this just now, so I just want you to sit and think about it. There's a thinking space. Just think for a little while. What is it really asking? Not how scary is it, but what is the question asking us to find? And for what value is g of x increasing? And once again, think, what is it saying in English? What does it want? Okay, so let's look at the first question, finding the values of a and p. And we'll go back to this, and I'm going to highlight g of x so that we can see it. And I'm going to rewrite the equations. Oh, I'm so sorry about that. It's a bit bumpy, but you'll be able to cope with it. G of x is equals to ax squared plus p. Now, if you remember, you'll remember that our p value is our y-intercept. So that's really nice. We can immediately replace that with -9. We didn't even have to think there. So now we have the equation of g of x is equals to ax squared minus 9. So how do we find the next coordinate? The next value, a. Yes, you are correct. We use a coordinate. So I'm going to substitute subs 4 and 7 into the new equation. So that means I have 7 is equals to a4 squared minus 9. And I'm going to solve for this, first by extending the page to give myself more space. And I'll take the 9 over first, and I've got 16a. Oh, this is going to work out very nicely for me because 7 plus 9 is 16, And I want to get rid of the 16 on the other side, so I'm dividing by 16, which means a is equals to 1. So my answers are going to be a is equals to 1 and p is equals to -9. So I would have shown all of my calculations over here, and that's how you should do it as well, but those are the two answers. So I hope you can see it's not that scary. Now moving on, the next question asked us to find the values of b and q. So once again, we need to look at our function. Now in h of x, our y-intercept is 23. So we can substitute that in immediately. So I'm just going to write over here, h of x is equals to bx squared plus q. Q is equals to 23. Therefore, h of x, and I'm writing nice and big here, is equals to bx squared plus 23. Now, in order to find the value of b, we need to substitute a point in. So let's go back to the graph and look at what points we could substitute in. Let's choose this point. And the reason I'm choosing that point is because it's going to be easy. It has the value of 3 and 0. And let's go back to here. So I'm going to substitute 3, 0 into the equation, giving me 0 is equals to b3 squared plus 23, which means I have -23 is equals to 9b, and b is equals to, what is 23 divided by 9? That's a horrible number. I'm just going to use the calculator. And remember, calculators can always help. So -23, delete, 23 divided by 9 gives me an answer of -23 over 9. I could have told you that, but it's -2 and 5 over 9. -2 and 5 over 9. Did I really have to do that? No, not really. It's the same as writing -23 over 9, but that just looks nicer. So those are my answers. B is equals to -2 and 5/9, and Q is equals to 23. If I'm feeling inspired, I could rewrite the equation and say h of x is equals to, and then it was -2 and 3 and 5 over 9, and blah, blah, blah. But I'm not feeling inspired, and I want to get on to the next question. Also, I'm running out of space. So the next question says, find the values for which h of x is more than or equal to g of x. Okay, so grade 10s. I want you to relate this now to a real life experience. When has someone been more than you? What kind of things were you talking about when this happened? Were you maybe talking about the number of chocolates you ate, or how tall they are, or what marks they had? When someone is more than you, it means they've achieved a higher level than you. So if we think of it as higher and lower, then it's a lot easier to think about. So when they're asking when is the one graph more than the other graph, they're literally asking when is the one graph on top of the other graph. And then they want you to tell them the domain for where that's happening. And remember, the domain are all the x values where that can happen. Now, it's impossible for us to write down every single x value, like x is equals to 0.111, x is equals to 0.11111. It just won't work. The infinite number of numbers between 0,1 and 0,11. It's a very complicated thing. So rather than writing down every single value, we write down an inequality, because that allows us to say all of the values in just one mathematical statement. Okay, so we're going to go back to the question and look at where h of x is more than g of x. H of x is the bottom one, and g of x is the top one. And where h of x is more than g of x is just over here. You see, at that point, h of x is above g of x. G of x is underneath it. So between -4 and 4 is where those are true. And that's how you would answer the question. You don't need to show any calculations, you just write it down. Okay, and we do have one more question to add to this. I'm going to slip it in very quickly. Where is g of x increasing? Okay, so if we look at it, if we're thinking of the bicycle going down the hill, that's decreasing height, isn't it? And then suddenly, at x is equals to 0, it starts increasing. So g of x is increasing from 0 and upwards, where x has a value of 0 or more than 0. Okay, grade 10s, when we come back, we're going to do the trig question. But for now, I want you to practice that stretching out. Maybe have a chat to your friend about what you found easy and what you found difficult. And talk about grannies in bikinis. We'll see you just now. Welcome back, grade 10s. Now we're going to look at our trig question. Now, you'll remember I said last week that people look at trig and they get scared, and I'm really not sure why. Other than the fact by the time that we do trig functions, you've done 4 other functions and you're feeling the pressure. But there really is nothing to be scared of with trig functions. They're probably the most simple functions you'll get. You just have to think through each one and relate it to its parent function. Now, you'll remember that the sine function started at 0, 0, then went up to 1, down to -1, and ended at 360 degrees. The standard period for a parent sine function is 360 degrees. Can you remember what the standard period is for a cos function? It's also 360 degrees. Tan function was slightly different. Remember, it had asymptotes every 180 degrees, and that meant the tan function would go up and up, up and up, and it would come closer and closer to the asymptote, but never ever touch it. Of course, this meant that it had a period of 180 degrees. So tan is a little bit different. It's like the ugly stepsister or whatever, if you're thinking of fairy tales, that is. I'm not saying just because you have a stepsister, she's ugly. I'm just making a comparison. Anyway, enough about my comparisons. Let's take a look at this question. Consider the graphs of functions f and g. Okay, let's take a look. Well, we have this function over here, which looks very much like a sine function, doesn't it? It goes up first and then comes down. It has a period of 360 degrees, and it goes up to 3 and down to -3. So it's not your parent function, but it's interesting enough. And then we have a tan function. How do I know it's a tan function? Well, it has these asymptotes. And these asymptotes are happening every 180 degrees, which makes me think that there's been no change to the period of the tan function. It's still just 180 degrees. But it does have a different shape, doesn't it? Because the normal tan function would start at 0 and then go up. And this one seems to be going down. We're going to have to think about this one, aren't we? Well, that was a rubbish graph, but you get the general idea. Okay, let's look at what the questions are asking us. write down the domain of g of x. What is the amplitude of f of theta, g of theta and f of theta. Determine for which values of theta f is equals to g, which is equals to 0. And g times f is less than 0. G divided by f is more than 0, and f is an increasing function. Now, while I answer all of those other questions with you, I want you to sit and think, what are these other questions asking? And don't tell me f is equals to g and things like that. I want to know, what are they asking in English? How would you describe this to your younger brother or sister? By looking at the picture. What would you say about the picture? Remember, look at the picture. Picture what's being asked. Okay, let's start by writing down the domain of g of theta. So we're going to go and look at the graph. G is our tan function. And our graph is being drawn only from 0 degrees to 360 degrees. So that means our domain is between 0 and 360, but there's a trick here, because there are places that G does not go to. There's a place, and there's a place. So we have to state that theta cannot be 90 degrees, and it cannot be 270 degrees. And the reason it can't be that is because the function will never cross over these lines. It will get closer and closer, but it will never, ever, 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 ever touch. So just to recap, domain means the x-axis values. And so for g of x, it's going all the way from 0 through to 360 or 360 degrees, but it does not equal 90 degrees, and it does not equal 270 degrees. Okay, the next question asks for the amplitude of f of theta. So grade 10's just to revise. With an amplitude question, where it's not a straightforward height question. A straightforward height question is asking what is the highest point. But with an amplitude question, it's asking what is the difference between the middle point and the height. Because we have a depth that's just the same amount. So what you could do is you could find out the total range, the difference between the high point and the low point, and you could divide it by 2. But generally, I find it easier to just look at the function and find the midpoint of the function and then measure to the top from there. Luckily for us, our sine function hasn't been moved anywhere. It's only been stretched by a factor of 3. Let's go back to the drawing so that we can see it again. And we go back and we see on the graph that our sine function goes up to a height of 3. It's there. It goes up to a height of 3. It also goes down to -3. So if we look at the center line through the function, we'll see that it goes up 3 and goes down 3, and that means our amplitude is equals to 3. So amplitude is equals to 3. Once again, this is not a thinking question. This is something you either know or you don't. And because you are clever about the maths you do, you're going to study what amplitude means, what domain means, and you're going to be able to answer those questions without thinking. Now the next question says, determine for which of theta f of theta equals g of theta, which is equals to 0. Now there are three different parts to this, or two different parts. It's asking where these are both equal, but also where are they equal to 0 at the same time. So if we go back to our graph, let's see if we've got another one over here. Oh good, we do. There are other places where they are equal to each other. If I highlight, there's a place they're equal, here's a place they're equal, and here's a place. But then we also have this spot here and this spot. But is that what the question's asking for? It's asking for when they are both equal and they are equal to 0. So in order to satisfy both of those, we need to only look at where they both intersect the x-axis at the same time with each other. And that happens at 0 degrees, 180 degrees, and 360 degrees. So if we write our answer, it's very easy. We just say theta is equals to 0 degrees, 180 degrees, and 360 degrees. Grade 10s, you'll notice so far that none of these questions have been difficult. And I have to keep telling you that they're not difficult, because you're going to keep looking at the next one and going, it's terrible, I can't do it, I really can't, but you can do it. You just need to think about, what are they saying in English? They must stop talking this lazy mathematical language, and we call it functional notation. And it's important that you know functional notation, but only so that you can translate it into English. Okay, so the next question we're going to look at, and then we're going to translate it into English again. The next question says, where is g of x times f of x less than 0? Okay, let's start by looking at what does it mean to be less than 0? What kind of numbers are less than 0? Is 2 less than 0? No. Is 1 less than 0? No. Is -1 less than 0? Yes, it is. Is -2 less than 0? Yes. So basically, they're asking, where are we going to get negative numbers? But now we need to look at this part over here. G of theta times by f of theta. How do we get a negative answer from multiplying two numbers together? What if g of theta was equals to -3 and f of theta was equals to -2? What would our answer be? Well, it would be a positive. Is that going to work? No. Why? Because we need a negative answer. So that must mean it will either have to be where g is negative and f is positive to give us a negative answer, or, sorry, let's just make that into a 0, or where f is negative and g is positive, and that will give us an answer of less than 0. So let's go back to our graph and look at it. So we're looking for when the one is negative and the other is positive. So like this point over here could have a value, a y value of 2, and this point over here could have a y value of -2. And 2 times by -2 gives us an answer of -4. So they suit our criteria between 0 and 90 degrees. But then suddenly we have them both being positive. And we know that if that's equals to 2 and that's equals to 2, 2 times by 2 will give us +4. So we don't like that. It doesn't work. But what about down here? Now they're both negative. Let's mark off over here, -2. -2 times by Negative 2 gives us an answer of positive 4. Do we like it? No, we don't. So then we've got to look over here, and you'll notice I've changed color, and I hope you've realized why. Because now we have 2, a y value of 2, and a y value of negative 2, and 2 multiplied by negative 2 gives us an answer of negative 4, which makes us happy. So once again, we have an area on the graph that suits our requirements. So the two places that suit our requirements are between 0 and 90 and between 270 and 360. So let's go write that down. Now I'm making a real mess of the graph, but I hope that it's helping you to get an idea of what needs to be done. So the answer was between 0 and 90 and between 270 degrees and 360. Okay. Now we have two last questions. This one says g of x divided by f of x is more than 0. And the other one says where f of x is an increasing function. Now you'll remember an increasing function is one that when you have to cycle your bicycle from left to right, you're going to be cycling uphill. So let's answer that one first. And now that I've made a real mess of this, I'm just going to highlight f in blue quickly so that we can still see what's happening. And if we think of cycling our bicycle, we're going uphill in this first part and uphill in the last part. So it's actually exactly the same answer as the question we've just done. It's between, and let's go back and go down, between 0 and 90 and between 270 and 360. Okay, now the last question, or the second last question, but the last one we're going to do for today, is asking where this value is more than 0. So it's asking for when are we going to get a positive answer. Now we know that if we divide a positive number by a positive number, we're going to get a positive answer. And if we divide a negative number by a negative number, we're going to get a positive answer. Which means we need both of the functions to either be above the x-axis or both of them to be below the x-axis. In fact, it's the exact opposite of this question above. This question asked for less than 0 when we multiplied the two by each other, and this question's asking for more than 0 when we divide the two by each other. So our answer is exactly the opposite. It's going to be between 90 and 270. And just to prove that I'm right, let's go back to the graph, and we see that between 90 and 270, they're both in the same quadrant. So now instead of being unhappy in those quadrants, we're now happy because we're going to get positive answers. Okay, grade 10s, we've done 3 great questions for exams. I wouldn't be surprised if you got these kinds of questions in your tests and exams. You are now ready to tackle any question ahead of you. Remember, ask for help from your friends, your family, your teacher, everyone. Have fun for the rest of the week, and we'll see you soon. Goodbye.